Good afternoon, all. Thank you for joining our today's webinar on understanding the PCB fabrication process. I'm Sairam, working as a team leader here at GSAS Microsystems. And today's webinar is a recording. If anyone having any questions during the presentation or during the demonstration, please type your question in the chat to discuss at the end of the demonstration. This is our today's agenda, where we want to discuss about the delivering what kind of data we deliver to fabricators, and what is the pros and cons of a native files which are shared to the fabricator, and what is fabricator's view on your design, and how you can control your design data, followed by demonstration, and we'll be concluding with somebody on the Q&A. Now let's discuss about the what kind of delivery options available to deliver your data to your fabricator. Here are three primary ways to transfer the data to your fabricator. You can email a zip file or complete a form on the PCB's vendor's website. Alternative offers and a newer innovative way whereby the designer can simply share the bare board fabrication file directly with a couple of clicks. In addition, the release package can be shared with the fabricator early in the process, and the design can be viewed within a browser without loading any software. Yes, what is a native PCB file Gerber pros and cons? There are two primary formats for delivering the PCB design data for fabrication, which is a native design file and the Gerber format. Let us take a look at the advantages and disadvantages of each. Ease of use of the designer, which is a pro, and coming to the cons for the PCB file. Manufacturer requires the original software, and a technologist with knowledge of the software is required. Contains too much information. There is a possibility of data corruption. And what are the pros of Gerber file? It is the international standard. Transfer the necessary minimum information. Control over the file generation process. We can compare the original file with the modified file from the manufacturer. It is more difficult for the manufacturer to make mistakes. What are the cons? Additional steps, exporting the files, required little customize of the model. These are the pros and cons of the PCB and the Gerber. What is your fabricator view of your design? The primary feedback from the fabricator will typically focus along layer stack design and placement, routing of the board. Level of technology standards, what materials used, compatibility of materials and structure, actually imbalance of the transition. They are the views of the fabricator on your design. The fabricator may suggest a change to the layer stack in cases where the dielectric layers have been incorrectly selected. In attempting to reduce the overall thickness of the board to achieve performance objectives, the designer may specify the prepared layers that are too thin. Often designers forget that the connector layers themselves have thickness, and that this thickness must go somewhere when pressing. It can be pressed into the material of the internal layer, dielectric material, and the resultant spacing between the adjacent layers will be unacceptable. It is recommended to more careful calculate the layer stack up by taking into account the thickness of the copper and dielectric layers. Using the board fabricated standard stack up recommendations can serve as a guarantee that the layer stack will be correct. Everyone follows another aspect to consider related to dielectric layers that may arise is the number of prepack sheets between layers. Many fabricators recommend, as a rule, the use of 2 layers of prepack to ensure the quality compression. However, not everyone follows the recommendations and may deviate from them by using 1 or 3 layers. In this situation, you will be offered an opportunity to adjust the layer stacker choosing from the existing range of materials that provide the parameters you need. Designers want to be sure to study the requirements for the layer stack-up and, if possible, use known good layer stacks either from within your organization or from your bare board fabricator. A manufacturer can offer to change the thickness or types of dielectrics used in the layer stack-up if they cannot guarantee that the transmission line will meet the requirements with the layer stack-up that the designer initially specified. For example, if designer requires impedance control traces and their stack-up does not specify the proper materials or does not take into account aspects such as repacked materials or does not take into account aspects such as thickness of the copper, edge by consideration, the fabricator will determine that they cannot assure the proper impedance and they may offer suggestions on changes to make in order to ensure the specifications are met. The total thickness of the layer stack-up may prevent the thicker boards with small wire diameters from being reliably fabricated. This is because the ratio of depth of the hole to the diameter of the hole is exceeded. This is minimum ratio is 10 to 1, and if this is exceeded, the problems may arise. This situation typically occurs in boards with complex HDI requirements. It is a good idea to pay close attention to the ratio shown in the design. Blind wires are especially sensitive to this depth to the diameter ratio. Every designer has likely thought it's always recommended to design a layer stack-up and that is symmetrical relative to middle plane. Deviating from this increases the chance of board warpage. In this situation, the fabricator may give designers input on the layer stack by intended to prevent board warpage. However, there was instance where a asymmetrical layer stack-up are feasible. For example, when heterogeneous materials are used, such as plain fiberglass, is combined with a high frequency materials like rollers. Additionally, sometimes inner layers are heat dissipated by copper with increased thickness. These are special cases which should be considered and analyzed accordingly. Now let's move on to the second subsection, when can manufacture progress a routing adjustment. This often occurs when the clearance between tracks of a same net are so small that the fabricator cannot guarantee proper production. In this case, such a clearance must either be filled with copper or increased. Of course, any one of the changes would require approval by the designer. This example considers a situation where the trace dimensions do not result in correct transmission line impedance for a given stack-up. However, in this instance, it is the fabricator that is proposing a change to the routing. Typically, the trace width of a single analog signals along with spacing in the case of differential pairs. RTM has two options for working with unconnected pads on on a special function doing work with the placement and routing. The other is setting when generating Gerber files. The first one is used to leverage doing routing, removing unconnected pads, providing more space for routing. The second one usually delete remaining unconnected pads by default when exporting the files. Manufacturers generally prefer not to use extra pads because they increase to wear of the drill. If for some reason you purposely keep another pads and put them in a Gerber file, you may want to mention this when ordering the bare boards from your fabricator. After all, the manufacturer can adjust as a part of the preparation process, remove the pads, and not even mention it. In order to improve the balance of copper in the board layers, the fabricator can add their own non-functional copper with your approval, but no one knows exactly how this copper will affect the performance of the board once the board is populated with the components. You don't want to wait for corrections from the fabricator. Balance the copper yourself before it is to fabricator. And finally, the last point that we'll mention is so-called antenna. There are traces that find their way in the design that are not connected to anything and at one of their ends, like see like this in the image. Now, how you can maintain or control your design data? If the fabricator provides us with the Gerber files that they have updated with their adjustments, how should we process? Even for simple board, comparing a set of production files manually is a serious task, and for complex board, it is essentially impossible. That's why Altim provides a special Gerber compatibility. It's available as one of the tool in the Altim feature workspace. And now we will demonstrate how we can use this. Now let us see how we can compare the Gerber which we have received from your fabricator with the existing Gerber with the help of the Altim 365. Yes, now I'm an Altim designer and this is my project. And you can see I have gone to the workspace. This is my Altem display workspace. I can access the same design content in the browser by clicking on this globe symbol. It allows me to open the Altem 365 workspace in the browser. From here, you can able to access all my projects, what and all I have managed through Altem 365 can be seen here. I just yes, you can see I have got a couple of projects, and this is a project where we're just talking about for the design, validation, and verification of the Gerber. And these are design content I have here, and I have the PCB, and you can able to see the PCB 3D, Craftsman, and bill of materials. And if you take a look at the releases, what are releases we have done using artificial AI will be shown here. As I told earlier, now still people used to save their share their the fabricators through email by using a file format. As we have mentioned in the presentation, we can simply release the Gerber and ascending data to the artificial AI workspace, and then we just simply select is sent to manufacturer. You can choose appropriate data to the appropriate vendor. Assembly, we can only say the assembly data, and fabricating, we can only say the fabricating data. Just by enter the email, and they can directly open the design what you have shared. I mean, that assembly data in the browser itself, and they can review and they can revert back with their suggestions. And if you click on open, I could able to open the same in a detailed window with all design information, the preview. And if you have shared a Gerber to your fabricator, and as you have explained a case, if there is a kind of some clearance issue you found, and he adjusts the Gerber. Once he did any adjustments, he has to take a prior approval from the designer. Once he send back the Gerber to you, how we can compare that Gerber with the existing Gerber? We just see. We just go here and just click on Gerber 2, and we can select the files, and it will ask you to drop a file from the Gerber. You can able to go to the downloads, and where the Gerber you have, you can able to select, and you can able to open, you can select. I have already uploaded multiple Gerbers. I want to see this Gerber which has been received from the fabricator. I want to compare this Gerber with the existing one. I just select this uh, file which you want to compare. The tool will automatically generates the Gerber comparison window. This is a Gerber which is generated by me, and this is a Gerber which I received from the fabricator, and this is a comparison where and all we have the differences. We have found, see, this is the fabrication one, and this is the current one. But means due to some it is at the board edge, you just try to maintain some clearance, you push it towards the right side. And here also we did some changes for the component, and he did some changes for the track. And here also he just the pad. You know, to see the lot of changes he did to maintain the proper clearances. Okay, here also a lot of changes he did. Here there was a minor change he did in this case. Here also there is a minor change. You can able to see at which area he did. Instance, he did some changes for the popper and for the solder mask and for the overlay. Top overlay means silk screen top. The screen they did some changes. You can able to see and layer wise changes. top paste. This is the where he did some changes for the drill. The Baya also updated. And this you can to get the a detailed view of your Gerber, which you have received from the fabricator, and you can have to quickly upload it to the identity file, and you can have to compare with the existing Gerber which you have shared with the fabricator. This how you can easily and quickly compare your Gerber data with that of this identity. Yes, to summarize, we have showcased you what are the traditional ways of sharing the files with the fabricator and how we need to define the stackup. And we also showcased about the pros and cons of the sharing the PC file and the Gerber file. And we have showcased about the stackup. And we have also showcased about the what you can compare the Gerber from fabricator with the existing Gerber you share with the fabricator, and you can roll back with your suggestion to the fabricator and to take it further. Yes, that's all from my side about this webinar and understanding the PCB fabrication process.